Hello, I am Oksana, and this is our thermal neutron diffractometer Zebra for single crystals. Neutron diffraction is a method to determine crystal and magnetic structures. Single crystal diffraction is a good method to determine the details of the reciprocal space in 3D. Powders unfortunately average this information. Zebra is a very good instrument to collect weak signals in extreme conditions, such as high magnetic fields, magnetism installed now, or very low temperatures. Here in blue you see a target where neutrons are produced. Then neutrons are flying through the channel to the monochromators, which are located in this red beton block, and then monochromators do reflect neutrons, and they pass then few meters to reach the sample. Now let's take a closer look.
On Zebra, we can use different kinds of sample environments. For example, here, a sample of a few millimeters is located inside this 10 Tesla cryomagnet. Before and after the sample, the neutrons can be precisely slid down to the required windows. This is done through high-precision motorized slits, which are essential to optimize the background of each measurement. On Zebra, 3 different detectors can be used. On this detector carriage, a point detector and a 2-dimensional detector are mounted in opposite directions. These can be easily swapped, like this, therefore we can quickly switch from a configuration where we search for signals or diagnose the sample to a configuration where we realize fine, high-precision measurements. For very demanding experiments, we can also disconnect this entire carriage, like this, and instead install this one. On this second carriage, the diffracted beams are first filtered through a graphite analyzer before reaching a point detector. All 3 detectors can be tilted far out of the horizontal plane. This allows extended access to reciprocal space, even using complex sample environments. Now, let's have a look at some data.
Using dedicated software at PSI, we can, for instance, visualize data from the 2D detector. We can thereby determine the angular positions of a few peaks and then easily determine the orientation of the crystal axis with respect to the instrument coordinates. Once this is done, we typically collect our data with one of the point detectors. Each data point is precious, and putting them together in a meaningful way is very important. It is therefore essential to have tools that ease this process and allow us to make the best possible decisions during experiments. For example, using the software, we can easily plot our data as a function of an external parameter such as field or temperature, showing the data in total or the fit parameters.